Greetings, ladies and gentlemen. This is the Silent Killer with FRQ Set 5, number 2. If you wish to see question 1, please go to the previous video. Anyway, let's begin. A 4 kilogram particle moving along the x-axis is acted upon by the force whose functional form is shown below this graph. The velocity of the particle at x equals 0, or the initial velocity, is 6 meters per second. Now, this is a force over displacement graph, which means energy must be involved, work. And work equals the integral of force dx. Now, what is the integral? We're trying to find the speed at 2 meters, so our bounds would be 0 and 2. Why 0? Because we know the velocity at x equals 0, which is 6 meters per second. Now, why is this graph important? Because the integral of force to respect to x is basically the area of this graph. So from 0 to 2, we need to find the area between 0 and 2. The width, the length is 2 meters and the width is negative 5 newtons. So the area of that is negative 10 joules. Why negative? Because this area is below the x-axis. If it is above the x-axis, then it will be positive. The work will be positive. So we end up getting work equals negative 10 joules. Now, by the work and kinetic energy theorem, you get work equals change in KE, kinetic energy. Work is negative 10, as we found before, and KE equals KE final minus KE initial. So KE equals 1/2 mVF, because it's final, equals 1/2 mVI. So 1/2, mass is 4 kilograms. We don't know VF. 1/2, 4. We know VI at x equals 0 is 6 squared. So 4 divided by 2 is 2, VF squared, minus 4 divided by 2 is 2, times 6 squared, so 2 times 36 is 72. Add 72 to both sides, and we get 62 equals 2 VF squared. Divide 2 on both sides, and we end up getting VF equals 5.57 meters per second. And this is V of 2. Part B asks, find the time of travel from 0 to 2 seconds. There are many ways to find a solution to this problem. Personally, I will use Newton's second law. Net force equals ma. The only force acting on a particle is f of x equals ma. And from 0 to 2, the force is always negative 5. So we will use that as our force. Negative 5 equals mass is 4, a. Divide 4 on both sides, and we get a equals negative 1.25 meters per second squared. But we're not done yet. We have to find time. And what equation has acceleration, velocity, and time? The acceleration formula. A equals delta v over delta t. We can expand delta v to vf minus vi over delta t. We don't need to expand that because that's what we're trying to find. IC for t, you get t equals vf minus vi over a. Plug in the numbers, 5.57 minus 6 over negative 1.25. And we get t equals 0.34 seconds. Time it takes for the block to go from 0 meters to 2 meters. Okay, part C. Find the impulse experienced by the particle between 2 meters and 4 meters. Now, like before, we can find work from 2 to 4. So we have a rectangle of 1 meter times negative 5 newtons. This block will equal negative 5. And this is a triangle, so we have 1 times negative 5 divided by 2 equals negative 2.5. And we add those up, and you get, let's write this down first, work equals 2 to 4 fx dx, and net work will equal negative 7.5 joules. Next, we'll find the VF, a V of 4 basically. Same thing. Work equals changing KE. I'll skip a few steps. Work equals 1/2 mvf squared minus 1/2 mvi squared. So work is negative 7.5 this time. Mass is 4, so this would be 2vf squared minus 1/2 4. Vi this time is V of 2, which is 5.57 squared. So you get negative 7.5 equals 2vf squared minus 62.05. I'm a genius, I can do it instantly. Just kidding. We do the same thing, add 62.05 to both sides. 54.55 equals 2vf squared. And we end up getting Vf equals 5.22 meters per second. But we have to find impulse, not Vf. But how do we do that? Well, we know that impulse equals to the change in momentum. And change in momentum is equal to mass times change in velocity. And what's the change in velocity? Our Vf minus Vi, mass is 4 by the way. Our Vf, as we found, is 5.22 minus Vi, which is 5.57. Multiply that and we get our impulse as negative 1.4 newtons per second for part C. Now part D, they wanted to find the impulse again, but from 3 meters to 5 meters. So this is, as we found, this triangle at 3 to 4 is negative 2.5, and from 4 to 5 it is positive 2.5, 1 times 5. So basically they cancel out and your total energy is 0. So work will equal 0 joules this time. Okay, it's the third time you're seeing this, so let's make it quicker. 0 equals 1/2 m. Okay, 1/2 m will always be 2 Vf squared minus 2 times Vi squared. Now we don't actually need to know this because we can prove that Vi will equal to Vf. So we can move Vi to the other side to get 2Vi squared equals 2Vf squared. We can cross out the 2's and then screw up both sides and we get Vi equals Vf. How is that important? We'll go back to the J equals delta P, impulse equals momentum. J equals m Vf minus Vi. Now, since both of these are equal, this will cancel out to 0, and we end up getting impulse equals 0 newtons per second. So basically when there is no difference in velocity, there is no change in momentum, and therefore no impulse. Part E. Find the particle's speed at x equals 10 meters. Okay. So here's 0 and here's 10. 10 is like pop, pop. This means it's constantly going here forever and ever and ever. So start from 0. What I notice here is that 1, 2, 3 rectangles and a triangle, 1 triangle, and then 1, 2, 3 rectangles. So since this is below the x-axis and this is above the x-axis, we can essentially cross all of this out, because this whole thing from 0 to 8, the work equals 0, total work. But we still have from 8 to 10, and now we equal 2 times 5 equals 10 joules. So the total work from 0 to 10 is 0 plus 10, which is equal to 10 joules. Okay, 10 joules. Okay, you're probably tired of seeing this, but work equals delta KE. Work is 10, and KE is 2Vf squared minus 2Vi squared. So we're going from 0 to 10, so Vi is the velocity at x equals 0, which is 6. So 2vf squared minus 2, 6 squared. 10 equals 2vf squared equals 6 squared times 2 is 72. Add 72 to both sides. 82 equals 2vf squared. 41 equals vf squared. And we get vf equals 6.4 meters per second for part E. Now, part F. Part F states, does the particle turn around at some point and head back toward the origin? Clearly explain. Okay, so as we see in this graph, actually now I'll erase it now so you can see better. Velocity starts by moving in a positive direction. Now, this force creates a negative acceleration which moves the block back. But the force stops being negative and starts pushing the block back forward at x equals 4. So at x equals 4, all the negative force has been exerted. So x equals 4 will be where the velocity is slowest. And as we found out in part C, our velocity is at x equals 4 is 5.22 meters per second. So that is the slowest the block has gone from 0 to 10 meters, which means it has not turned around because velocity has not changed from positive to negative. Now, part G asks, repeat part F, if v equals 2 instead of v equals 4. Okay. So from here, yep, G. So, we'll do this again. I know you don't like it, but okay. Total work will equal, we know that v equals 2 at x equals 0, so we'll go from 0 to 4. Like before, 4 is the slowest the block can go because, or the most negative the block can go because that's after all the negative force has been exerted, dx. And that's, there we go. Area at from 0 to 4 is negative 5, negative 10, negative 15, negative 17.5 joules. Okay. So delta work equals KE 2vf squared minus 2vi squared. Negative 17.5 equals 2vf squared minus 2v. This time vi is 2. So we get negative 17.5 equals 2vf squared plus 2 squared is 4 times 2 equals 8. Move to both sides. Negative 9.5 equals 2vf squared. Let's actually move this here. Divide 2 on both sides, we get negative 4.75 equals vf squared. And the square root of that is vf equals negative 2.18 meters per second. Now, I know what you're asking. You can't square root negatives. It'll just come out as an imaginary number. But in physics, our negative just indicates direction. So we basically take the square root of 4.75, then plop the negative there afterwards to show that it's moving left, not right. And as we see, the velocity is negative, while the initial velocity is positive, which means over the course of the block's movement from 0 to 10 meters, the block's direction changes from positive to negative at some point between 0 and 4. So, answer to part F is no, but answer to part G is yes. And that is all the parts. Thank you for watching. See you in question 3.